In this video, I will explain find the Fourier transform. Find the Fourier transform of the following signals. First one, x1 of t is equal to x of 1 minus t plus x of minus 1 minus t. Second one is x2 of t is equal to x of dt minus 6. Third one, x3 of t is equal to d square by dt square of x of t minus 1. Fourth one is x4 of t is equal to dou of t plus 1 plus dou of t minus 1. First one, solution. x1 of t is equal to x of 1 minus t plus x of minus 1 minus t. By using Fourier transform properties, according to time reversal property, time reversal property of the Fourier transform. Fourier transform of x of minus t is equal to x of minus omega. Next, time shifting property. Fourier transform x of t minus t naught is equal to e power minus a omega t naught x of omega. Fourier transform of x of t plus t naught, left shift and right shift, is equal to e power j omega t naught x of omega. Here consider x of 1 minus t, that is equal to x of minus t plus 1. Therefore, Fourier transform of x of minus t plus 1, by applying this property, t naught is equal to 1, t naught is equal to 1, e power j omega into 1 x of x Fourier transform of x of minus t. Fourier transform of x of minus t, small x of minus t, that is equal to e power j omega. Fourier transform x of minus t, time reversal property, that is x of minus omega. Next one, x of minus 1 minus t. Next one is x of minus 1 minus t. For x of minus t minus 1, apply this property. Therefore, Fourier transform of x of minus t minus 1 is equal to, apply this one, e power minus j omega. T naught value here is, t naught value is 1. Minus sign means minus 1 minus j omega into 1. E Fourier transform of therefore Fourier transform of x of minus t. Therefore, e power minus j omega x of minus omega. x1 of t is equal to, we know that x of 1 minus t plus x of minus 1 minus t. Therefore, Fourier transform x of t is equal to, apply Fourier transform. Therefore, x1 of omega is equal to Fourier transform of x of minus t plus 1 and Fourier transform of x of minus t minus 1. This one is e power j omega x of minus omega plus e power minus j omega x of minus omega. X of minus omega is common term. E power j omega plus e power minus j omega. Both numerator and denominator is multiplied with 2. Therefore, 2 of x of minus omega e power jx plus e power minus x by 2 is cos x. That is cos omega. First problem, next completed. Second problem, Fourier transform of x of x2 of t. Fourier transform of x2 of t is x of 3t minus 6. That is equal to Fourier transform of x of 3 is common term, t minus 2. First, we have to apply scaling property. According to time scaling property, Fourier transform of x of at is equal to 1 by mod a x of omega by a. Here x of 3t. Fourier transform of x of 3t is equal to, here a is 3, positive, mod a is equal to a for positive values. A is equal to 3. X of omega by 3. Consider this by applying time shifting property. Therefore, Fourier transform of 3 into x into 3 into 3 minus 2 is equal to, according to shifted by 2. After shifting, e power j omega minus 2 j omega naught. T naught is equal to minus 2 j omega naught in Fourier transform of x of 3t. Therefore, e power minus 2 j omega naught Fourier transform of x of 3t is 1 by 3 x of omega by 3. This is the second problem solution. Third one, Fourier transform of x3 of t is equal to, x3 of t is d square by dt square x of t minus 1. This is also a shifting property, shifted by 1 unit. That is e power j omega t naught. T naught is minus 1. That is minus j omega, and the Fourier transform of d square by dt square According to differentiation, time differentiation property, Fourier transform of d by dt x of t. Suppose d whole power n by dt whole power n x of t is equal to j omega whole power n x of omega. Here n is equal to 2. Here n is equal to 2. Therefore, Fourier transform of d square x of t by d square is equal to j omega whole square x of omega. J square is -1 minus omega square x of omega. Substitute this value in that expression. Finally, e power minus j omega. Fourier transform of d square x of t by dt square is equal to minus omega square x of omega minus omega square e power minus j omega x of omega. This one is third one. Find the Fourier transform of x4 of t is equal to dou of t plus 1 plus dou of t minus 1. Fourier transform. That is equal to Fourier transform of dou of t plus 1 plus Fourier transform of dou of t minus 1. According to shifting property, shifted by 1 unit plus 1 e power j omega t naught is 1. Therefore, Fourier transform of dou of t. Here shifted by -1 e power minus j omega. Fourier transform of dou of t. E power j omega, Fourier transform of dou of t is 1. E power minus j omega, Fourier transform of impulse function, that is 1. That is equal to e power j omega plus e power minus j omega by 2 into 2. 2 cos omega. 2 cos omega. With this, 4 problem solutions are completed. If you like this video, please subscribe the channel for further updates. Thank you.